Okay, so in last class we have seen how we can interact with uh, Hugging Face, Olama, OpenAI, and Grok based LLMs. Okay, so today we will see what are the parameters in LLM model. Okay, so let's go to OpenAI playground. Yeah. So if you see, there are some parameters: temperature, maximum tokens, and top P. Similarly, there are other parameter in means LLM. Okay. So these parameter basically control the behavior of LLM model. Okay. LLM model uh, control parameters. So these are like settings for LLM model. Okay, and these are very important because based on these parameters, the behavior of LLM model will change. Okay, so what are these parameters? So there are different parameters. So first parameter that is most important is temperature. First I will list all the parameter, then I will explain one by one. Okay, then max tokens. Third, context. This is not okay. Context window. Context window. Then fourth, top P. Fifth, top P. Top K. Uh, stop sequence. And okay, temperature max token. Just a minute. Stop sequence. Yeah. So these are mainly these 5 parameters are main. Okay. Okay. Temperature, max tokens, context window, top P, top K. Okay. So in LLM model, so let's first talk about context window. Context window or length, context length. So context window or context length. So in any LLM model, okay, so context window is basically the maximum length of message that model can take. Okay, based on number of token. Okay, so this is basically a context. So context window is the maximum length of message in terms of token. Okay, so the maximum number of tokens as an input that model can take, that will be basically a context window. So it is like every model has different uh, context window, and more the context window, better. It is like let's say in LLM you input some message. Okay, so let's say you just ask what is uh, Python, simple message. Okay, so how many tokens? I'm just roughly saying this has 6 to 7 tokens. Okay, so uh, we cannot send a message. Let's say in LLM, the token or context window is, let's say, 20. Okay, 20 is the, let's say, context window. Okay, for some LLM, then we cannot enter a message greater than 20. Okay, we cannot enter a message or we cannot ask a question greater than 20 tokens. So so this is about mainly let's say in some LLM model. Let's say if you want to basically give some book directly, if you upload some book to the, let's say, chat GPT or any other LLM model, so that book as an input, it will take or not depend on its context window. So let's say if the book is the total number of tokens in that book is greater than the context window of that LLM model, then it will directly tell this this is out of context. This the number of token, or it will not take that input. Okay, because that context window, it the input message that you are passing to the LLM surpass the context window. So how to check the context window? So different model have different context window. So let's say if I see GPT-5 context window. So here it is saying 128k tokens. So it means 1,28,000 uh, tokens, means the maximum uh, the question that we are asking to the LLM, or anything that we paste to the LLM in a time, we cannot enter more than this number of tokens. So this model can only understand up to this number of tokens. Okay, if you add more tokens, then it will throw error. Okay, so similarly okay, let's see different GPT models context window. Hmm. Hello, sir. Just a minute. Um, so if you see here, the GPT 3.5, the context length was 4096. Okay, let me know down. GPT 3.5, the context length was 4096. Then GPT 3.5 Turbo, the context length was 8192. And then GPT-4, they increase it to 1,28,000. And then GPT-4o, uh, again 1,28,000. Similarly, if you see the Llama model, the context length is 4096. Okay, for Llama 2. Okay, and then in Llama 3, it was 8,000, and now it is 1,28,000. Yeah, and in Gemini, so have a context window of 1 million tokens. So 1 million is roughly 10 lakh. So I think Gemini has a maximum context length. Okay, uh, we can search also Gemini context window. Uh, so it is 1 million tokens. So that is maximum, I think. In all LLM, Gemini can have a maximum number of maximum context window. Gemini, it is 1 million. 1 million, and Anthropic, it is I think 2 lakh. 2 lakh. Maybe we can check once again. Anthropic is 2 lakh. And okay. And in Cloud Enterprise, it is a 5 lakh token. So this means that, let's say, if I have to basically the 4009, if I start with GPT 3.5, so let's say if I give some book, so maybe let's say in single page, approximately, let's say 1000 token is there. Okay, so if I upload a book, let's say more than uh, so for example, so let's say I want to upload some book in LLM model, and I want to ask question from that. Okay, or let's say I upload some book to the LLM model and ask that model to basically summarize. Okay, so in GPT 3.5, the number of context window was 4K. Okay, and I am assuming that, let's say, one page having roughly 1000 tokens. Okay, so if I have to summarize this book, I can summarize only 4 pages, because uh, if I enter 5-page book, then it will throw error. Okay, so this is about GPT 3.5. In GPT 3.5 Turbo, the context window was 8K. So now I can, let's say, 8 pages I can upload. And in GPT 4 and latest also in GPT 4 and 5, the context window is 1,28,000. So this means that um how many pages I can, so 128 pages I can upload at a time. Okay, and if I talk about Gemini, so it has 10 lakh. Uh, 10 lakh. So it means I can upload 1000-page book. Okay. And similarly, if I talk about Anthropic, so that is also up to 2 lakh. So it will have 200 pages. Okay. So this context window, based on the context window, of that model that is already fixed. You cannot change the context window. So it's depend on the model only. So based on the context window, uh, the message that you are pasting to, let's say if you are pasting something in chat GPT, some text, so that should not exceed the 128,000 token limit. Otherwise it will not digest, or it will not process what you want from that text. Okay. Yeah. Aditya, tell. Okay. Soumya, sorry.
So actually, I just wanted to know that how we can understand that how much token like are being used while we still are typing any prompt. It depends on the text or it is something else.
Your voice is not clear. So can you come again? Means
Yes, yes. Can you hear me, sir, now?
yes. Now we can hear you.
So I just wanted to know that tokens are basically depend on the text we are typing or we are pasting, or the as you have said that we can upload a book like 3 to 4 pages. So
Mhm.
how we got to know that how much input I will provide that will use this much token?
So the token. Uh, so the token is mainly. Uh, what is token? So it is mainly 4 character, roughly. So actually, different LLM has different way of defining. Some are taking 4 characters, some are taking 3.5 character, but all the token, one token equal to 4 character. Okay, so
Okay.
let's say if you have a book, 4 page book. Okay, so and characters can be, if I define characters, what what I mean by character. So character can be uh, literal. So literal means it can be A, B, C, D, means all the letters, right? All the letters. Similarly, it can have a special symbol, has, at the rate, all sort of symbols, emojis, and what else? Full stop, comma, all those things. Okay, so based on all this only, so this length should not be more than 4 character for one token. For one token, it will be 4 character. So let's say if you upload a book, so it will extract the text from all the text, and based on that, it will see how many tokens it is required, right? So yeah, so that is how mainly we can find the number of tokens. You
Okay,
got
sir.
it, or
Got it.
yeah?
Yes, sir, yes, sir, got it.
So this is for means text, but we can also upload images, videos, right? So for there, the token is, for image, the token is depend on pixels. Okay, and so I will tell how the token um, uh, calculated for images. Okay, so it is based on the size of the image, the number of tokens. So that is well documented in the OpenAI. Means if you want to know the pricing and how many tokens, let's say if you upload some image, so how many tokens it will consume. Okay, so that uh, uh, so this is how basically tokens get calculated for uh, string, or if you upload, or if you type some message, right? So yeah, so the context window is how much model can understand. Means let's say if you input some message, so based on, so maximum length of that message or maximum token that you can input to the LLM model, it dependent on the context window. Okay, yeah. Okay, now, so LLM, how first we will see how LLM generate answer. Okay, so let's say again the same thing. Let's say this is a LLM model, and you ask something. Uh, let's say, what is the capital of India? Okay. Yeah. Now, so this is the input to the LLM. Okay. And so LLM will generate one token, or yeah, one token at a time, or okay. So let's say, what is the capital of India? So it will generate first answer by, so it will generate the, first it will generate the, okay. Then it is a recursive process, okay. Then it will again add this the to this message, okay. Okay. Now after that, the uh, it will predict next word capital. Then it will also add here capital, then of India is Delhi. Okay. So you given some input to the LLM, but LLM will generate one uh, one token at a time. Okay. So it take all means, in LLM input it will take parallelly. Okay. Input it will take parallelly, but output will be sequential. Okay. So it will generate one token at a time. Okay. So let's again see it through some example. So before that, every LLM has some dictionary. Okay. LLM has some, LLM has, sorry, LLM has dictionary. So dictionary is normal dictionary that we have seen. Na? Means, so LLM also have some dictionary, and you can also treat it as a list of vocabs. Okay. So this list of vocabs, maybe it has, let's say, all the things, the all the means all the things, or all the string that we have seen in dictionary, right? So from A to Z. So similarly, in LLM also, all the uh, different types of uh, different types of word are there in his list. All, even special character, emojis, all the things it will have. Okay. So for, let's say, if I talk about OpenAI, so it has around 50K. The length of dictionary is 50K, and they hasn't reveal what are the things that are present inside the dictionary, or means what are the word that are present inside a dictionary, character, emojis, all those things they haven't revealed, but they just tell that they have 50K thousand, or 50,000. The list of dictionary is 50,000. Okay. Now they will generate, means let's say if they generate answer, the word will be from here only. There will not be any out of word. Okay.
So
हाँ
basically, a dictionary is an key pair value, right? So
uh, it is not a miss. This dictionary is different. Uh,
okay,
this is basically a list of. Suppose you can assume this is a normal dictionary. Okay, but
okay,
here it doesn't have any meaning, right?
okay,
So in normal dictionary we see some sort of meaning as well, right? there some word is there, then their meaning is there, right? But here no, only the list of words or list of vocabs you can say. So this you can treat list of vocabs.
Okay.
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 So it will try to capture the all possible words, emojis, special character. So this is basically inside this is what inside the this dictionary or maybe vocabs, the list of vocabs. Okay. So every model has different list of vocabs. So uh, in OpenAI the length is 50k, around 50k. In Anthropic it is much, it is around I think 1 lakh, 1 lakh. So it Anthropic has more, um, the vocab list is more. Okay. So now let's say if you ask some question again, uh, what is the capital of India? Okay. So LLM will first see this message. Okay. See this message, and based on that message, it will go to dictionary or vocabs. Okay. Uh, let's, I have this box, vocabs. I will, so here let's say 50 total, 50k vocabs are there. Okay. 50k vocabs are there. So LLM will first try to, let's say what is the capital of India. So I said that it will generate one token at a time. Okay. So based on this input, what is the capital of India, it will basically for all the word it will assign some probability. Okay. It will assign some probability. Okay. So let's say uh, so the first letter the. So if it generate the, so it means that the will have a highest probability. Okay. Uh, for example, let's say in this vocabs, if I write some, sorry, let's say it has the capital of India is Delhi and Mumbai uh, are no, yes. So similarly, let's say there are 50,000 total words. Okay. So now if a user is asking what is the capital of India, okay, to the LLM model. So LLM model will assign, since it has intelligent, so it will assign some probability to these words. So for example, I know it will start from the. So maybe the will have, let's say, probability of 0.9 and 0.1, uh, 0.01, and overall similarly, let's say this also 0.2. This is how. So this is how it will assign some probability. Okay, because it has intelligent, it will know which word, which will be the first word. Okay, in output. Now, so since the has highest probability, so the first output will be the. Okay, then it will again send this the to here. So the now the input will be what is the capital of India. Plus means not a plus, it is actually just plus means what is the capital of India, the. Okay, just adding the string. Okay, so now it will be what is the capital of India, the. Again, so now next time it will pass who this all input to this. Now the probability will change. Okay, so initially it was 0.9, 0.1. Now the probability will change. Uh, let's say here 0.01. I think capital should come next. So it will assign some 0.95 and similarly other. Okay, so every time it assign new probability. Okay, now the capital. Okay, so now this time the capital will also come here. Okay, so the now the next input will be what is the capital of India? The capital. So now it has all these things. So it will again try to predict next word. So again it will assign some new probability. Maybe so next probability later is off. So it will 0.01, 0.03. I'm randomly assigning these probabilities. Okay. So just for example, because all this calculation done internally through LLM, 98. Okay. So now the next word will be the capital of. Based on it will choose which has the highest probability. Okay. So it will choose the model based on mainly which has the highest probability. So off has the highest probability and it will again come back to here. Okay, so this is how the generation happening. Okay, so if you ask anything in chat GPT or any just a minute, chat GPT. Okay, let's say if I ask what is the capital of India. See, means it first started generated the then capital of India is New Delhi. So if I let's say describe India in detail. Okay, see, it's generating one, means it's like a streaming thing, like, right? So it first generated it doesn't have all the messages uh, in a single go, right? It first started with its CO, then line by line it is generating, right? In line also it is generating word by word. So it is not generating all the answer once at a time. It so all the LLM will generate one token at a time. Okay, but you are saying because that is very fast, so it may feel like that it's generating all the answer in one go, but it is generating one token at a time. Okay. Yeah, Adit, you want to ask something?
Yes, sir.
Huh, tell.
Sir, you told that for image, the token depends upon pixel. So in videos, how it depends, and for
So
audios,
so video consists of what?
um, a video consists of basically image and audio,
Huh. So for image I tell na. So how we can.
pixel,
Huh.
and for audio,
So audio have different thing. Okay.
yes,
So they have identified something like how to basically in audio also mainly they first convert into a text. So there are before that also speech to text model is there. Okay.
yes,
So anyhow we will see
yes, sir, yes,
that
yes,
and video audio part later. Yeah.
yes,
Okay.
sir.
Okay.
And one more thing, sir, like
Hmm.
what about the probability? Like you have said that it will check the close probability for that the capital of India. Like those are similar words, like similarity cosine or whatever it may be. The probability they check, but the answer, which is New Delhi, like how can it get guess that the same probability, like similar probability that we should give the answer as New Delhi? Why not Mumbai like that? So is that any mathematical logic around that, or Like it is already feeded that this one is there.
So this is already trained. The LLM
Okay.
model are trained, right? So they have uh, trained on a very large data set. Okay. So trained means they have given a set of input and set of answers. Okay. And
Okay, got it,
ba-
got it, got it.
uh, okay. So right now I do not want to go into that area. Otherwise, uh, there will be lots of mathematics. Okay. So I do not want to make it complex, but yeah, if um, so initially I want to start with this only. Later on, I will teach what is the transformer, okay, and how this thing is happening. But uh, for some people, this is means my objective is to do not make it much complex, and for different people, different level of because in some job scenario that mathematics is not required, okay, and for if some people want to go deeper, then we will uh, I will teach that also. But yeah, so initially my purpose is to cover all the people, okay. Yeah, so this is how the generation happening. Okay, so it generate one token at a time, and then it pass that token to input to the again to the LLM model, and it generate the next token. This is how the generation happening. Okay, now the temperature. uh, Temperature. So temperature is very important parameter. So based on the temperature, you can change the probability. Okay, you can. So temperature value generally in some model it is start from 0 to 1. In some model it is 0 to 2. Okay, so temperature basically decide the randomness in the answer. Randomness in the answer. So randomness means uh, so let's say if you ask something to chat GPT, or so let's say if you ask some question, write a poem, okay, and let's say first time you ask and it has given some poem, okay, but you do not like that poem, you want you said that again basically uh, recreate the poem, okay, so it will again, let's say, input the same thing or output the same thing. So this is like having a low randomness, okay, or because you are getting the same output again and again. So if the temperature is low, let's say if I set temperature low, low means it is between 0 to 0.4, okay, 0 to 0.4 or maybe 0.2 also. 0.2. So when you set the temperature low, it means that every time it will generate almost same answer. Okay. When you set temperature low, it will or so LLM will generate same answer for same question. Okay. So if I ask what is the capital of India? Okay. So no matter how many times I run, it will the one with word will always be there, Delhi. Okay. Uh, so in that, how we can control the temperature? Means let's say if I put low temperature, so it will almost every time it will say the capital of India is Delhi. But if I increase the temperature, so it will rephrase those things. Okay, so it may use some new word. Delhi will be there, but it will use some new word also. Okay, so temperature basically decide the randomness in the answer. So randomness means every time, let's say if you ask the same question uh, 2-3 times, so if the temperature is low, it will generate almost the same answer. So this temperature we generally set low for let's say factual answer, law, uh, law law case, medical. Okay. So where the answer correctness is very important, there we generally set temperature to low. Let's say if you are creating some banking chatbot, okay, and user is asking, so you do not want to give any false information. Okay, so there you generally set temperature to low, 0 to 0 point. Generally we set 0.23. Why not 0 if we want factual check? Because we do not want to uh, 0.2 means there will be slight variation in rephrasing of the word. Okay, uh, so that that liberty we want to have. So for that only 0.2 or 0.4. Um, but yeah, so for that only we are slightly moving from 0 to 0.2. Okay, now where we will require a high temperature. So high temperature is generally required when, let's say if you ask ChatGPT to create a poem or movie script, okay, or some essay, okay. So there you want to have a creativity or some image as well, okay, some image. So there you want to have a uh, here you are not checking any factual check, right? So here you want some creativity. So high temperature means high creativity. Okay, so every time if you ask some question, it will show some creativity. Means it will uh, the poem may be different. uh, if you set high temperature, so it will use uh, different words, or for movie script also, so it may generate different things every time. Okay, now that is good. So for high temperature means 0.5 to, let's say in some cases it is, because all this temperature parameter in, let's say in OpenAI, it is mainly 0 to 1, I think, and in Anthropic or some other model it is 0 to 2. Okay, the maximum value. So that you can check. But yeah, so this is about high temperature. So, but how this is, the question is like how it is deciding, or how it is basically this temperature affecting the randomness in LLM model. So let's say, so there is a very famous example, the cat set on the. So let's say there is a fill in the blanks. Okay, the cat sat on the. So let's say I have a list of word: mat, uh, gate, um, sofa, uh, and let's say floor, uh, house, and let's say train, flight. Okay, so let's say the cat sat on the this. Let's say I simply input this part to the LLM. Okay. Now, initially, let's say when the temperature is low. So let's say if the temperature is around 0, the probability was, let's say it probability is 0.9, and here 0.012, 0.03, and 0.01, 0.02, 0.01. Okay. Okay. Just assuming that all the probability will be 1. Overall summation will be 1. Here I think it is more than 1, 1.001 I think. But yeah, just assuming that maybe 0.5, here also 0.5. Okay. Now I think it is 1. Okay. Now when the temperature is, let's say I'm assuming when the temperature was 0. At that time, this is the probability, and the answer will be basically the cat sat on the mat. Okay, because mat has highest probability. Okay, now let's say if I increase the temperature to 2, so temperature increase it to 2. So if I increase the temperature to 2, so it will basically divide, let's say 0.9 by 2, 0.02 by 2, and 0.03 by 2. So everything it will divide it by 2. Okay, so 0.9 divided by 2 will be let sorry, 0.9 divided by 2, so it will be 0.45, and this will be 0.02 will be 0.01, and this will be it will be 0.015. Okay, so see, and so this means once we increase the temperature, see the probability of that mat get reduced. Okay, this probability will get reduced. So now it is giving some more probability, means these are no, so let's say if I simply take these three part only. Okay, 0.04, 0.01, and 0.05, 0.15, and on that, if I basically apply some sort of thing like 0.45 plus 0.01 plus 0.015, okay, and if I divide like that, so it will come around, let me 0.45 by, so it will come around 0.6. Okay, and similarly if I again normalize this other one also 5, so this will be 0.01 divided by, it will be 0.013. See, so earlier it was 0.01, now it probability increase. Okay, so here if you see here, the probability of mat was very high. Because of that, there is a slight improvement in other probability. Okay, when we divide by the temperature, let's say if I take some other case, let's say in the same thing, mat, uh, ground floor, house, and kitchen. Okay, same thing. And let's say here now the probability is, let's say 0.5 or 0.6, and here it is a 0.3. Here it is a 0.2, and let's say 0.05, and here also 0.05. Now if I do the same thing, let's say temperature equal to 2. Okay, now the new probability will be, I have to initially it was this thing. When I set the temperature equal to 2, the probability will get changed. So now new probability will be 0.6 divided by 2. Everything we need to divide by 2. Okay, so it will be 0.3. Okay, and second will be 0.15. It will be 0.1. It will be 0.025, and it will be 0.025. Okay, it will be format this one, ground floor, house, and kitchen, and then we have to normalize as well. So this normalization will be, first we have to sum all this thing. So the sum of this will be 0.3 plus 0.15 will be 0.45, 0.55, and this will be 0.6. Okay, so 0.6 will be the overall summation. Means if I add all these things, so it will come around 0.6. Now, if I first start with mat, the new final new probability will be 0.3 divided by 0.6. So it will be around 0.5. Okay. Similarly, for the next one, the grow. So for grow, it will be 0.15 divided by 0.6. So it will be 0.4. Okay. 0. Just sorry. And 0. Yeah. So here the probability will get changed. Okay. So when we set temperature, so the value, uh, the probability who having a lower value, they get increased. So here it increased from 0.05 to 0.8. Okay. So it probability get increased. So once the probability get increased, so let's say if you ask some question, uh, and it may choose this value as well. Okay, the car set on the, means the cat set on the house or kitchen also. So if you increase the temperature, so this may not look perfect, but this is how the temperature works. Okay, So it is basically, so there is a one function called softmax. So the thing that we are doing here, so this is basically applying softmax. Um, Actually, there is some mistake. So in softmax, it is uh, e to the power ji divided by sum of e to the power I equal to 1 to n. So because of that only the normalization is not, but this function we need to apply. Okay. Uh, so if you see the softmax, maybe can check it here only. Softmax. Okay, yeah. Okay. So let's take the same thing, 0. Uh, 0.3, 0.15, 0.1, 0.025, and 0.025. Apply softmax. Yeah, see, the new probability will be this one, 0.238, 0.2, 0.195, 0.018. Earlier it was 0.6. Means let me note down it here. 0.3, 0.15, 0.1, 0.025, 0.025, 0.238, 205, 0.195, 181, 0.181. Yeah. So now earlier the probability was initially when we start at that time the probability was 0.6, 0.3, 0.2, 0.05 and 0.05, right? So we have applied softmax first. If I talk generally, we call this as a logit. So logits divided by temperature. Okay, and on that we have applied softmax. Okay, so this output basically, so these are, let's say, logits, and then we apply softmax on top of that. So the new probability will be this one. So earlier it was 0.6. So see, from 0.6 it came back to 0.238. So earlier the difference was 0.3. Now the difference is very less, right? So the probability will get change. So because of temperature, this probability will get change. Let's say here only, if I set, it will know what I'm talking about, temperature to 0.2 on 0.6, 0.3, 0.2, 0.05 and 0.05. What will happen to this in LLM? Uh, so in case of when I apply that probability equal to 0.2, so it will first divide this thing by 2, so it will come around this thing, right? Now after, if I apply the softmax function, so the new probability will get this thing. So when we set the temperature to low, the probability will get increased. Means, let's say probability will get increased means 0.6 was highest probability, that get increased, and the above, the lower probability will get reduced. Okay. See, the lower probability, the 0.3 becomes 0.15. Only the highest probability get increased. Okay. And let's say if I set temperature to 2. So the same thing, in that case, the probability will get, the highest probability will get reduced and the other probability will get increase. So now the chance of selecting the other value get increased. So this is how, based on the temperature, this value will get increased or decreased, means this probability. And based on, because everything is about probability, the token or the word that it generate, it depend on the probability of that word. Okay. Yeah. So this is how temperature controlling the output, okay, that it generate. And similarly there is a, not similarly, so there is a max token. Okay. So let's say, so max token is mainly uh, the maximum number of token that it should generate. So let's say if you set max token equal to 50, okay, so the LLM model will not generate token or output more than 50 tokens. Okay. So let's say if you have to control your cost, okay, so then use, let's say if you set token to max token to 50, so LLM will stop after generating 50 tokens. Either your answer is complete or incomplete, but it will stop after 50 tokens. So this is max token is basically output uh, output capping. Capping means you are capping that the LLM will not generate more than 50 tokens in output. Okay. Let's say if I ask describe India. Okay. So, and I set max token equal to 50. So let's say in a single line around 10 tokens are there. So it will not generate answer more than 5 lines. Okay. So this is, so based on the max token, if you set max token, then it will help to reduce your cost. Otherwise, it if I ask, let's say describe India, it may generate 100 to 100 lines. Okay. And in 200 line, let's say in each line there are 10 tokens. So in 200 line, it will have a 2000 tokens it will consume. Okay. So with the help of max token, you can control the number of token that LLM generate. Yeah. Any question till now?
Sir, so that means that if like we are most of the people using are the free version of ChatGPT, so that's how they implement the pricing for the like when they ask for the upgrade the version or upgrade your account. Like if we have used like a limit for a day, so it all depends on the token and how
Yeah.
they
Yes.
how they do the capping.
Yes. Yes. It all depend on the tokens, but
Okay.
yeah, and also there you cannot use the, so So in GPT there are different model, right? So
Yes,
they are
yes.
not giving you access of the premium models.
Okay.
Their purpose is to just collect data from you. Okay. So that's why they have make it free and also to make it popular. So but the main objective is so that is means most of the company giving free chat, uh, means if like
Yes, yes.
Perplexity or all those things, they provide you free chat, but
Sir,
they are not
you
giving
said
the.
that
Mhm,
they are collecting the data to train their AI model, right? So
mhm,
that means if we are asking something and if you are providing any input to the any AI
mhm,
model, so
mhm.
it in real time they are collecting it in their model like training, or first they analyze that what kind of data we have provided, then it use that data into their backend.
So means they haven't said how they basically train the model using those data, but the idea
Okay.
was, means I am assuming, and it is means you can easily later on you also able to identify how they are training, not complete picture, but yeah, some picture you will get. So right now, let's say if you ask some question, okay,
Yeah.
and then okay, this answer not look good, give some more thing. Okay, means let's say if you write some
Yes.
code, means given some code, and you also paste the bug that you are getting. Okay, now he
Okay.
suggested some code, then you again run that code, and again the bug came,
Okay.
then again you reply. So now it know okay what works and what doesn't work, right? It has the information.
Okay.
So this information, so there will be some categorization based on the message. It will categorize this belong to coding, these belong to some other thing. Similarly, so there are different types of categorization before passing to before creating a data. Okay, creating a data means fitting that data in the, let's say for coding there are separate set of database. For
Mhm.
mathematical there are separate set of database. Similarly, there are for different application, for medical there are different set of database. So they have all those data set, and also let's say if you upload some pictures, that picture is in their uh, database also. Okay, so what works and what not work, they have all this information. Before that they have like stack exchange, so there mainly people ask question, means earlier before LLM they generally try to see the answer there only, right? uh, Stack
Yes.
exchanges, or I forget the name. uh, so they're mainly, so from that only they have trained their model to fix the bugs. So they have collected
Okay.
all
So
sort of.
that means I can assume that any any AI model is not using the real time data. They are using the own data which they have already. And if you are providing something, it they are collecting their data somewhere else, right?
Mhm, right. So they have their database, right? Recently,
Yeah.
if you heard the news that OpenAI collaborated with Oracle. Okay,
Yes. Yes.
so before that collaboration, Oracle owner was not a richest man. So there is a 300 billion deal. After that, that Oracle owner become the richest person in this planet. Okay,
Okay.
so
Got it, sir.
yeah, so they are storing all the data that you means for API. Uh, for API means let's say if you use their API, they said that they are not collecting data, but for chat, they directly tell that they are means in their I think privacy or means where they give information. So they
Okay.
mention that they are collecting your data when you are using a chat GPT. Okay,
Yes. Yes.
that
I have
chat.
seen that, sir.
Uh-huh. Even Anthropic also now for this chat one. Earlier they are not collecting, but now they also modify their rules, and now they also start collecting the user data.
Okay.
So and also means this model not trained very frequently. Okay, so generally they let's say they waiting for 5 to 6 months or 1 year, and then they trained, means they internally they trained, but they do not release those model to you. So that, let's say GPT-5 come, uh, before that it was GPT-4, and I think
Yes,
six
sir.
seven after 6 7 month of gap they released the GPT-5. So if any new
Yes.
model release, then they have the data till that point. So let's say, if I release some model now, so they said that this LLM model get trained on till this year, okay, or till this year data. They don't have the recent information. For that they are using the web browser. So they are adding the tools. So if you see in, if I show you chat GPT, so there
Yeah,
are
I
like
got it, sir.
more में web search. If you
Hmm.
so it may automatically, let's say if you ask something, what is the current price of some stock, it will automatically assign web search. Okay, so let's say what is the current price of Tata Motors. Okay, searching the web. See, right?
Yes.
Every so it automatically assigning the, okay, this question need web search. Okay, so but
Okay.
here the web search is not there, right? So one thing
Got it,
is
sir.
that it can intelligently assigning the, based on the question it will assign what sort of tools required to solve this problem. So tool means it, tools can be a web browser also. Okay, and yeah.
So I can assume that like Google, if we want to search something,
Mhm.
we go generally everyone go to Google, right?
Mhm.
So somehow if we have the any credential or a kind of API, we can
Mhm.
implement it into our AI model, and based on the user input, it will search for that input on the web. And if
Uh-huh.
he has the data, it will provide the information from our data source.
Right, but that will be costly. So it will basically search for, let's say, 5 6 website. So if
Yes.
you read the content from the 5 6 website, so how
Hmm.
many letters are there? Means how many words are there? Right? There will
Okay.
lot of word, and then first it will take all those word, and from that only it will filter. For filtering also it will apply LLM. So it will charge that cost as well. So
Okay. So it is
yeah.
a very long process, I think.
And so it's a means it's a costly process.
Hmm.
It will not take much time, but it's a costly process.
Okay. Got it, sir.
Uh, yeah. Any other question?
Yes, sir.
Mm-hmm. Adit.
Sir, suppose you told that this ChatGPT means this LLM models take one token at a time as input. So
No, no,
no, no,
not one.
output.
Uh-huh.
Yes, out. It
Mm.
takes gives one token at one time.
Mm-hmm.
My question is why is it so? I mean, if we increase the number of token or decrease the number of token at a time, is there any effect?
I'm not convinced. The LLM can generate one token at a time. You cannot
Yeah, this.
change its properties because it is depend on the encoder decoder architecture. So encoder part can take all input parallelly, but in output the decoder part can generate only one output at a time.
So, sir, is there any specific reason for this limitation?
So I said na, that is a decoder architecture.
So that is the because of architecture.
Yes.
Okay. And sir, one more question. Is there any relation between context length and output token?
Context length and output token.
Yes.
No, no. So context length is the maximum number of input that you can give to the LLM. Okay.
Yes.
maximum number of input in the sense maximum number of input tokens that you can provide to the LLM. And let's say if that token get exceeded, then it will not generate any output. So that relation you can assume, but there is no other relation than that.
Okay, sir. Thank you, sir.
Okay. So this thing will become much more clearer when we do the practical or hands-on. Okay. So yeah, so temperature we have seen, max token we have seen, context window. So in interview they generally ask is from these parts are these three part. What is the effect of temperature? What is maximum token? What is context window? So they ask because that is, let's say if you work in a company, the costing will be depend on some token, something like max token, and not just costing, also the answer that LLM is giving, it depend on the temperature, right? So they want to know whether you know what is the temperature and how you can, let's say if you want to have a factual checking or factual answer you want, at that time if you know how you can using temperature you can control those things, then so they want to know all those things like what is max token, temperature, and context window. Similarly, there are some other thing like top P, top K that we will see in next class. Okay, so these are main 5 parameters that we should know, and interviewer they will ask. Okay, most of the time, what are these things? Okay, so that's it for today's class. Uh, Next class, can we take tomorrow as well? Uh, Tomorrow class will not be very lengthy. I just want to finish that top P, top K, and some hands-on on that. So I think it will be 40 to 45-minute class.
Tomorrow, can we keep it in evening or afternoon?
Uh, okay. Maybe okay. Then we can meet it on Monday only. Okay. Yeah.
Okay, sir.
Okay. Thanks, everyone.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you.